hope you all had a good lunch here.
That was the wrong question you were asking, Sishwan. They would have had something and came.
Okay, you must have had lunch somewhere? Yes, I'm sorry then. So it's good that you have lunch because usually post-lunch sessions are always drowsy. We have one of the brightest speakers which I'll be introducing more. So first of all, I welcome Dr. Vishnuvardhan sir, who is the Director of National Institute of Medical Statistics, Indian Council of Medical Research from New Delhi. He's come all the way from Delhi to give this talk. First of all, please give a big round of applause. Today's theme.
Why don't we invite Dr. Vigyan?
Yes. Okay. So I request Dr. Ahmed Ibrahim sir to escort Dr. Vishnuvardhan sir to please come out to the dais. Today's theme is the next 25 years of science and technology, and you are the next 25 years for all of us, and it's important that this talk would be very important for you. It's a good topic. It is said that the queen of sciences is mathematics, none other than it is said by Frederick Gauss, the greatest mathematician, and to us the queen of mathematics is statistics. We have a statistician here. He's of course the king of statistics in medical statistics now, but we also have the king of computer programming. Sir is not only a statistician, but he's also a computer programmer. So he's not an able hand for which a good statistician is very important for any research, and he's the core of all the research projects we have at NIN. Sir has been working for more than 25 years in various capacities at NIN and at NIMS. He has over 3 decades of experience in planning, executing and analyzing data for several large-scale community and clinical-based research studies in the domain of nutrition and health. His research focuses on the development and application of innovative and appropriate statistical methods for analysis of large and complex data, which we call big data now. His work also encompasses several evidence-based and policy-relevant research studies. He has recently been part of the impact of COVID-19 on MCH services in India. I've been one of the NIN has been one of the centers. He's also an administrator for Clinical Trial Registry India. It's a free and online public record system for registration of clinical trials being conducted in India, which has been made mandatory by the Drugs Controller General India. He has served as an international consultant for various international agencies such as UNICEF. He has more than 125 papers published in national and international journals and over 20 papers to his credit. He's guided several postgraduate students towards obtaining PhD degrees in the area of multivariate data analysis, meta-analysis, and statistical methods in AI and big data analytics. He's a person who does few but really good, in the words of Gauss, few but right is his mantra. He has done 2 apps for NIN, 2 big apps which are available online. One is Count What You Eat, where you can actually go to the website and see what is the calorie count you have that comes from the food you have taken, and also the Nutrition Atlas. This is also a very good platform where you can understand the epidemiology of nutrition, both undernutrition and overnutrition. To his credit, he has many other achievements, but with this, I end my words and I request Dr. Ahmed Ibrahim sir to honor the guest with a bouquet. The last time Sir came, Sir received 5 minutes of was on the stage. Sir received 5 minutes of ovation for becoming the NIMS director along with our director. So again, once again, a round of applause to bring back the memories of those achievements.
Good afternoon.
Good afternoon, sir.
Post-lunch and statistics is very lethal combination. Statistics and mathematics. So I'll try to, as simple as possible, to make you awaken. So I'm really grateful to the organizers, especially Dr. Banu Prakash Reddy. I think you know him very well. who is actually insisted me to come over here. I always have fond memories of this institute. Almost 27, 28 years. I know inch and inch of this institute because in my tenure, the actual internet lines were laid down. So I used to go to the room and see whether that's been laid down or not. And I'm happy to see my old colleagues here. And I would like to thank Director of NI, Dr. Hemalata, Dr. Banu, Dr. Sabara, who has actually in touch with me and invited me. And I have my senior colleagues, Dr. Babu, Dr. Padmaja, Dr. Ayesha, and I always call my junior colleagues that Tamullu, all are there. So I'm very happy to be here. I also very happy to see the young generation. At our age, we were not knowing this artificial intelligence or big data. Only we were having some big computer, which is a completely room full of computer with a very small memory. So therefore, now you are at least lucky to have everything. World is in your palm top. I mean, in your palm, you can see everything there. So I will try to give this whatever the time they have given to go through what is AI, what is artificial big data, and how mathematics. I was telling them statistics is the queen, but unfortunately I am not queen. So so therefore I will go through this, and I think I also expect questions from you because this is a new topic. Even at this age we are learning this. I am the head of the artificial intelligence ICMR. So when I took over, I was not having much experience in that, but it is not very difficult if you have the basics of mathematics, statistics and computer knowledge. So thank you very much for coming all the way. I think you are from colleges?
Yes,
How many of you data science people are computer people? Many of you? But everyone will use the Facebook, I know. Okay, thank you. So I'm coming from the Institute of National Institute of Medical Statistics. Statistics, you know, our colleagues also know. People like statistics, people dislike statistics, people hate statistics, people curse statistics, but everyone needs statistics. So therefore, in that premise I'm starting. So prediction analysis, or what we call the artificial intelligence now. Artificial intelligence is nothing but prediction. So it is not very new. Even Mahabharata there were predictions. There were gambling scenarios. So in the prediction analysis, who was the top class predictor, a great AI scientist at that time. So what had happened? There was a tree called Vipitika, where innumerable number of leaves and fruits are there, which no one is able to count those because everyone is afraid of that. Then Rituparna, there is another king, thrown a challenge to Nala. You know Nala Damayanti? Yeah, Nala. I'm coming to that. That can you count and estimate how many leaves are there or how many fruits are there? Then he cut one twig and estimated the entire tree has 5 million leaves and 2000 fruits. That estimation, everyone thought that it was correct. So what is the result of that estimation? Nala got back his queen or his lady love Damayanti. Therefore Mahabharata has given you eternal love. Nala Damayanti now we call as eternal love. Not like the Vinushka love. What are the love stories you know? Vinushka, Brad Pitt and Angelina Jolie. Not that. Is the Nala Damayanti is the eternal love story the Mahabharata has given to us. That also it is involved in some kind of prediction. So the prediction he has got back his Damayanti back. So that's the kind of, so it is not new. Prediction we do always. So whenever you do something olden days, when you don't have anything, you take the rice, grain of rice, you see whether the rice is cooked or not. Now you have a rice cooker, it gives 3 whistles, then you take out, eat nicely. It was not like that before. So every time we are doing the predictions, fine. If you see this, a physicist, an engineer and statistician went on hunting trip. They are walking through the woods. When they spot a deer in the clearing, the physicist calculates the distance to the target, the velocity and drop of the bullet, adjusted and fires, missing the deer by 5 feet to the left. The engineer looked frustrated and yelled on him, "You forgot to account for the wind, give it here." After licking the finger to determine the wind speed and direction, the engineer snatches the rifle and fires, missing the deer by 5 feet to the right. Then the suddenly statistician cheers and oh, we got it. What does it mean? Average or left and right is center. That means statistics means center, averaging. So averaging the things are the center. That's been done. The statistics is nothing but averaging. So what is the artificial intelligence does for you the extra? You see this. If you average these two weights of two individuals, you will get the average weight of you or me. Is it not? One is very fat, another is very thin. So statistics tell you the average weight as the average weight. But artificial intelligence also go further one step, says that one is thin, one is fat. So what can I do? That kind of a scenario you can create with the AI. So that is the advantage other than what you are using the conventional statistics. Fine. So since it is the 25 years what we have to do in the future, if you see the technologies, the development of technologies over a period of time, there was lull in 1750 to 1850, there are very few inventions. From 1850 onwards, actually the takeoff of inventions, a lot of inventions have taken place. And in 1950 to 2000, the inventions are mostly on the basis of data science and in terms of computers. Actually, the internet and mobiles have reverberated the world. The entire world has changed its scenario with the internet as well as the cell phones. So, if at all some of you are mathematics people, some are statistics, some of you are computer people. So, if you go back to 30-40 years, it is, we call that even our scientists hypothesis testing. Hypothesis means you have something in mind. By virtue of giving iron tablets, the iron hemoglobin will increase by 1 gram per deciliter. That is our hypothesis. You take some experiment, you get the data and do the analysis. That is the hypothesis testing to evidence. And after 20-30 years, now conventional statistics have changed to advanced modeling like multivariate. Multivariate means you are using more than one variable to predict. Suppose you take weight and height and say weight is related to height. Then also you add the age to the weight and also the socio-economic to the weight, like that is a multivariate. So you have the more strength of prediction. Now, small computing too, now the artificial intelligence and big data. So that is the scenario of change. But basic concept has not changed. A plus B whole square remains A plus B whole square. So artificial intelligence will not tell A plus B whole square as A square plus B square minus 2AB. It also tells A square plus B square 2AB. So but the way it be its application, the way it has got into precision, so the precision mode have changed a lot. If you see this, we in the beginning, we are with the statistical theory, we learn statistics and mathematics. We take the tabulations and averages and we use the probability and statistics and Bayesian methods. Some of you also know Bayesian methods. You know what is the Bayesian method? You will have the pre-assumption and do it and do the data analysis and also evidence-based medicine or evidence-based meta-analysis we call it. Means everything is evidence. Meta-analysis means segregating of the many studies so that the policy can be implemented very effectively. Finally now the AI and big data on the top it is sitting and also commanding you what you do. Then what you do with the predictions, what is the use? So it is used for decision making and you use some tools, strategies, finally it is useful for society. Everything is for society. Therefore, the difference between the statistics and machine intelligence is, or machine learning is, so statistics emphasizes on the averages, articulation of the hypothesis, there should always be something to prove. The goal is to operational effectiveness, less need to specify what need to go into the model. So as I shown the two figures, it automatically captures that one is thin, one is fatty, and what are the corrections that should, everything it takes care. So that is the advantage of machine learning, means it also thinks something. Now coming to, I'm again like a picture now, I'm going by flashback I am going. So this is the end. Now what are the analytical inventions that have been taking place in the early centuries of 1900, 2000? What are the inventions that have made us to analyze the data? I think you must be heard of this name, Gauss. So everyone says a bell-shaped distribution, normal distribution you call it. Many of you might be knowing that. Suppose someone you pick say 30-40 people here, measure their weights and heights, put in a graph that will exactly look like a normal distribution. Normal is bell-shaped distribution. So it has its own property. After that, actually the study of statistics have gone into another route. Previously people were not knowing this. So if at all you don't follow the normal distribution, whether you can use the data, you cannot use the data, that is again a question of exploration. That is done by Gauss, which is called a normal distribution. Even all our biological scientists, they always want to follow their data to be normal. Otherwise, there are some corrections will be made. That is a different issue. Another one so normal distribution talks about one set of data. Your weight follows normal distribution. Your height follows normal distribution. But your fathers, suppose I took 20 fathers and I took 20 daughters of them, whether their weights and heights are correlated. It means bivariate. It means 1-to-1 relation. Whether if I increase one value, other value increases. If I decrease other value decreases. That kind of a relation, if you want to establish, that's called a correlation. You call correlation. That is been invented by Carl Pearson. That's why it is called Pearson correlation coefficient. So after this, lot of relational attitudes or relations of the variables have been established. Then lot of hypotheses have been proved. Then comes the student t-test. I think many of you, even if you are in a BSc statistics, you know that student t-test. So that has got its own advantage. If you want to compare two groups of experiments, whether they are same or not, two means are same or not, that's in use. That's a student. Why it is called a student t-test? So actually his employer did not allow him to work in the regular time. That's why he has worked in the t-time. That's why it's called t-test. So he has the student is the pseudonym of a pen. So that's why it is called a student t-test. So this also has helped many biologists to prove their hypothesis. And okay, actually the father of statistics is Fisher. I think R.A. Fisher. I think how many of you heard about his name? Fisher. Raise your hands. So offhand he has raised. Okay. So he is the one who has made most of the statistics possible. For example, ANOVA, analysis of variance we call. I think some of you may be knowing, and also the discriminant function analysis, which is now frequently used in the artificial intelligence. Means, can I discriminate between the good and bad? Can I discriminate normal and undernourished? Like that. That analysis also, which we call the discriminant function analysis, done by Fisher. So this is the correlation. How it look like? One is negative, another is positive. What does it mean? If I increase one value, others also increases. That called a positive correlation. If I increase one value, others coming down, I call as a negative correlation. The shapes are like this. Fine. So before this, I am telling hypothesis-driven research. So hypothesis means some claim. We have some claim that I am proving it. For that, he is the man, Neyman theorem we call, which is called a testing hypothesis, which some people may not be knowing. Our scientists know that. Null hypothesis we call. We start with no difference. We will prove that there is a difference. So this is being proved by this man, Neyman. And he is the father of statistics of India. June 29th is being celebrated as a statistics day on the name of P.C. Mahalanobis. So what is his invention? His invention is the Mahalanobis D square. Mahalanobis D square now is frequently and very thoroughly used in the artificial intelligence, because he has invented Mahalanobis distance. That means that suppose you have 30 people, you have the weights with you. Okay, so I will compare every weight with the other weight. If at all your weight is 0, that means that your weight and her weight is 0 means you are close. You are called similar. If it is there, they are dissimilar. Therefore, that is artificial intelligence does the same thing. It compares, says whether similar or not, then it puts you in one basket. It compares another basket. So they are called clusters. So that the characteristics of the cluster is within that basket all are similar. When compared to other basket, they are different. So that his theory of Mahalanobis D square is very much useful in artificial intelligence. Now, he is the great grand man. 101 years still is there. Still he is keeping his health very good. Professor C.R. Rao, who is only short of Bharat Ratna, every other award, every honor he has got. He is the advisor to US government also even now. So actually he is the one who actually statistics is only theory before. He is the one who made the theory as well as application of it. So if at all you have any time, instead of browsing some other thing, you browse about Professor C.R. Rao, you will get enormous information about him. Fine. That is the mathematical and statistical part of it. Now, utilizing that theory, we also use the computers. Otherwise, previously when we were studying, when we were post-graduation, for conversion of 20 by 20 or 30 by 30 matrix, we used to give the computer the problem and used to collect the information, result in the morning, means the 12 hours it used to take. Now it is 12 seconds with the power of the computer you have. So that is the change it has been made. If you go through the history of computers, actually history, it has started around 18th century, 1801, where Joseph Jacquard, a French merchant and inventor, invents a loom that uses the punched wooden cards. From there onwards, the concept of computer started. And the father of computers, which you all know, who is he? Charles Babbage. Very good, Charles Babbage. So from there onwards, the concept of computer, giving input, doing some computations, getting out. So that is in 1821. From that onwards, there are a lot of changes. Ada language has come. Holorith design. Holorith means even we did here in NIN. So suppose you want to give the data, you will punch the data in cards. That is been passed through some photoelectric effect. Then the electrical this one, when it goes to holes, it will identify A, B, C like that. That's called punched cards. So like that, 70s, 76. In the 76, Steve Jobs, who is he? Apple. How many of you have Apple phones? He rose 2 hands. Okay, very good. So Apple phones we have will be look differently. Always you keep like the back Apple. Very good. So in 1976 actually the Apple computers have been introduced. That too on the Fool's Day. You know that? April 1st. So now they are making fools of us. Okay? 1981, again, the major giant of computers, IBM, has introduced its personal computer. From then onwards, actual computer revolution has started. Everyone is able to access the computer. Previously, there were no access. Whoever have in the field of computers only used to get access. After the personal computers, everyone, irrespective of their subject, they used to buy the computers or the computers are available. And also the Microsoft Windows 85, the Apple Macintosh Mission in 84, and 93, actually the GUI, what is GUI? Graphic User Interface has started. From then onwards, there is no looking back. So lot of changes. Even today you buy i7 Intel, tomorrow it will come i8. So there is no end for this. Fine. And also how it has been classified into generations. The first generation, simple UNIVAC and IBM, very big machines. Even 100 KB RAM, it had occupied almost this room, big computer. And 59 to 65, the second generation, where you have the COBOL. Even anyone heard of this? COBOL, Common Business Oriented Language. Actually, with that language, America recruited so many people that has come, because of that problem, because the year is 2000, 1999 to 2000 onwards. So 99 they put, afterwards they don't know what to put. Then the problem has come. Many people have gone to work on this, who are known, who are COBOL programmers. And third generation is the Pascal Algar, fourth generation is the IBM again, fifth generation onwards, everything, artificial intelligence, C, C++, so all these things have come. Fine. Now comes to the data. So data, now previously it was oil, now it is the data. Which country has the data, that country is richer now. Because India also now Honorable Prime Minister Narendra Modi ji is called the digitization. So So now innumerable data sets have been created. So now data is no dearth of data. Fine. Then the Clive Humby, a British mathematician, coined the phrase data is the new oil. You all know that oil-rich Gulf nations transformed from camel to Cadillac car. 50 years, 55 years or 60 years back, they were going by camels only. So now you see. So they will have the Rolls Royce using as a taxi. Okay. So just as a crude oil is transformed into more useful products, raw data needs to be pre-processed before it can be used for analysis. First is the input of the data, which is fed into the algorithm to produce predictions. Second, training the data, and third is testing it. That's what AI is. AI is nothing but train, test and leave. So how best you do train the data, that best your accuracy of the AI. You all wondered, every day we almost create 25 quintillions of bytes of data. So you write on the paper and count it. Like that you do it, no? 1, 10, 100. How much it is? You will not. That much data you will generate every day in the world. How this much data is being generated? So if you convert that into how computer understands that, generally people say 100, 1 kilobyte, but actually 1 kilobyte is 1024 bytes, not 1000 bytes. For the simplicity of the calculation, they put 1000. It is not 1000, 1024. That's the binary, 2 to the power of 8. So you say byte is the simplest one, 8 bits. Kilobyte, 1024 bytes. Megabytes, 1024 kilobytes. Gigabytes, terabytes, petabytes, and finally GOP byte. That is after 30 zeros. That much data you have. Can you count that? So for storing that, how much storage you require? So much of storage. So this is the strength, this is the magnitude of data that is available in the world. How you are getting the data? What is the source of data? Apart from your surveys, apart from your research, that is very meager data. But the open source data which you are getting through photographs, for example, you are all use the Facebook, I know that. Even you say, no sir, I am not using, you are using. So Facebook shares around 300 million photos a day. 300 million photos a day. So this is my friend's photo, this is my neighbor's photo, this is my dog photo, like that you go keep on sending, the Facebooks. Like that, 300 million photos a day you will share. Instagram, 100 million photos per day it will share. Every day, 3 billion photographs are taken from the smartphones. 3 billion photographs. And users, WhatsApp uses 2 billion active. WhatsApp every day, 2 billion active users. More than Indian population, 1.5 times. And Gmail has 1.8 billion active users. 1.8 billion. Twitter has 400 million active users. And coming to online browsing, Netflix. How many pictures you have seen in like Netflix? Okay, Netflix uses almost 64 million hours per day. Per day, 64 million hours you will watch. YouTube uses 5 million hours per day streaming. And also Google Chrome, 5 billion searches per day. Can you imagine this data magnitude of this? So now you start your data science. Till 25 years you will not have any dearth of either knowledge or job if you really work on that. This much data is available, open source. So this is now called a big data. Why this is a big data? I am coming to that. Big data is not only big in size, there are some characteristics, I will tell you that. So this is every 60 seconds, this is the data you generate, every 60 seconds per minute. So 98,000 tweets you do. Already someone might have done already tweets here, sitting here only. Nearly 7 lakhs status reports you send. Almost 7 lakhs searches you make within a minute. 1.1 million instant messages you send. And 168 million emails you send. So that is 1 minute of data. So this is the magnitude of data you are getting. So now coming to what you do with that data. So it's almost a junk also. Sometimes what do you do with that? How do you do the meaningful conclusion with that? For that, you not only need the computer skill, you need lot of statistical computations. You need a lot of analytical thinking. We need lot of error-free updated data quality issues. So all these things, just like that, you know the program and apply and get the output. No, you will get garbage in, garbage out. Right? So therefore, you have to use lot of techniques to get that. Fine. So what is big data? So the big data is collection of big data used in volume, right? Yet growing exponentially with time, yes. It is data with large size and complexity, yes. And also big data is also data but with huge size. That's fine. But these are the characteristics of the big data. There are 5 V's. Actually, there were 3 V's. Another 2 V's have been added. Volume. Yes, it is volume. Then you can ask me how much volume is volume. I don't have any answer for that. Because now 1 terabyte no one is bothering. 10 terabytes now no one is bothering. So volume you cannot define as much volume as you can. Velocity, speed. So you have huge data, but you don't have the speed. Then you go on doing the processing, you never get the output. Therefore, you need the speed and variety. So variety, I am also, next slide I will show what variety is. Veracity means, I was telling you accuracy. How do you make sure that the data which you are utilizing or analyzing is accurate in nature? And value. So finally, how do you make it a more valuable outcome? Fine. So I am telling you, I told you that variety. So what is the variety? This is the variety. We only knew, many people, we knew that, we know only structured data. Means, suppose I ask a biochemist, hemoglobin value, creatinine value, they have, everything is structured. They don't know what is unstructured data. Even I don't know 15 years back. Mostly we use the structured data. Then, subsequently, semi-structured data. Something you have numeric, somewhere you have the text, like that semi-structured data. That is also acceptable. Quasi-structured data. That means that textual with erratic formats. So generally, we have the format. Computer how understands 1 to 5, one value, 6 to 10, another value, 7 to 15, another value. So computer cuts it exactly in those places and grabs that data. That is structured. Unstructured, one is 1 to 5, second record you got 1 to 4 only. Then how computer understands? Actually, it knows that only 1 to 5 it cuts. Otherwise, what happens? The next record, next value it will cut. There is a danger of data being merged into other data. So therefore, this is the one. Unstructured data is very important for big data. Unstructured means there is no structure. It is just like that erratic. How do you pick the data and analyze? That is where the big data comes into picture. So if at all you don't know, you have to learn these techniques to analyze the data. Generally, people say it is Hadoop. 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 How many of you heard about it? Yeah. So Tirupati is raising his hand because he has did his PhD. Okay. So this is having so many modules which you have to learn for databases, for extracting the data, for analyzing the data, for reading the data. So there are so many things which Hadoop does. Okay. You not only have the big data in your hand, that also attracts you the ethical problems. Just like that, you cannot do the analysis and say, so all the men are useless. Like that, you have done the analysis, but that will attract ethical issues. So therefore, how do you go about it? Ethics are very important. Protecting human autonomy, promoting human well-being, ensuring transparency, fostering responsibility, ensuring inclusiveness, promoting AI that responds to sustainability. Actually, ICMR is also trying to release the ethical artificial intelligence ethical guidelines, which we are struggling since 6 months. The committee is every day they are posing some questions. We are not able to, even with the secretaries here, we are not able to. So therefore, ethics are very important. So therefore, big data means big opportunities. When you get the big opportunities, you should be in a position to understand the data, to analyze the data, and you should be in a position to computerize the data. So there are 3 aspects which you should understand, analyze and computerize. So if at all you know that, you have a big opportunity. Now, since it is a medical institute, how healthcare and big data, our big data will be effectively utilized in the healthcare. It is in terms of the descriptive analysis, or in the diagnostics, or in the predictive analysis, or in the prescriptive analysis. So even in COVID time, we have been using this in the predictive analytics. So taking the past data, we are able to predict, are we able to predict the future data with some accuracy. So the more the accuracy, the more the validity it is. That's why many times we predict that will fail, because that will not have the accuracy. Fine. So many healthcare solutions with the big data. For example, even in the primary care, clinical description support, and visualization. Mostly now people, suppose you go to the lab, you get not only get the results, you also get some visualization, graphs and all. So that gives you more kind of visualization. Data, medical records, genomic data. Now the huge data now actually being deposited through genomics. I think where is he? Okay, our molecular person. So therefore, therefore, the molecular science or genomics data or bioinformatics data, that is huge data they generate. So therefore, the application is diagnostics, preventive medicine, and precision medicine, or medical research, cost reduction, population health or public health. So these are the aspects which the big data is being used. Now, the big data you have, the analytical techniques you have, now how artificial intelligence comes into picture and makes your analysis more precise and more faster. So, this what is artificial intelligence? Why this is called artificial intelligence? Or generally it is a machine learning. So we will train the machine and ask the machine to perform. So if it is you perform one time, you perform a million times, because you train the machine. Because the machine is very fast. If your training is right, so when your training will become right, when your prediction model is right, your mathematical model is right. So once you train the data, the artificial intelligence or machine will make so many kind of iterations. It doesn't do any mistakes. Whatever you have done, it will do. But if at all you want to repeat that, for you it will take a lot of time. If you train and give it to AI, it is million times faster than you, it performs. Therefore, what is artificial intelligence now? It is not only the increased accuracy, it makes a decision making, it solves the complex problems and also high level computations. So it automatically does. That's why now people are looking towards artificial intelligence, where you can repeat that with a high speed and high accuracy, if at all your model is right. Therefore, the machine learning is nothing but an application of artificial intelligence, and an ability to automatically learn and improve from experience and recognize the data patterns and creates rules rather than traditional programming. Generally, traditional programming, what you do, if this is greater than this is, if it is less than this, like that, no, you put some conditions. But AI, not only conditions, you train the data and leave it. So whenever that kind of pattern it identifies, then you know the Apple phone, many people have. So pattern if identified, immediately it understands that. So therefore, mostly AI is a pattern recognition, which we call the pattern it recognizes. Either it is a facial or it is a data, whatever it is. So this is the complex problem of artificial intelligence or machine learning. So these are the things, these are the ingredients we have in the artificial intelligence, right from data mining to statistics to pattern recognition to databases to neurocomputing or neural networks. So these are some of the techniques which you have to learn to become a really data scientist. So these are the layers, no? First, the machine learning, and what are the capabilities you should have, and finally what are the applications. So if at all you have the machine learning techniques and the AI capabilities, you will have intelligent agent, you have collaborative robotics, you have the pattern recognitions, you have the intelligent products, so on and so forth. Everything is in intelligence. You will get this. Therefore, the critical component of AI is prediction and is a critical input into decision making. Always prediction. Always prediction takes information which you have called data and uses it to generate information where you don't have. That's what you do. What you mean by prediction? You take the data where you have and fill up the gap where you don't have. That is simply the prediction. Okay? So, according to the Secretary of Defense, Ronald Rumsfeld of USA, he has categorized the AI into three groups. Known knowns means with rich data, machine prediction can work well. No one knows. You know something, you can. Both are known. Known unknowns. We know our predictions will be relatively poor in situations where we don't have much data. Unknown unknowns. So if sometimes something has never happened before, a machine can not predict it. It at least without human careful judgment. So machine learning means you will leave it to the machine. But if at all you are unknown and both are unknown, then your intervention is required. Therefore, there is no single right answer to the question of which is the best AI strategy. Researchers are predicting that familiars with machine learning tools for analyzing big data will be fundamental requirements for the next generation of physicians, or physicians means the physicians who take the help of data scientists. Therefore, so artificial intelligence in healthcare, you should train the data. It will give the early detection, research, decision making, diagnosis, treatment. Everything will happen if at all you use the AI in health. So I already discussed you. So artificial intelligence, medical imaging, that also we are doing here in ICMR. So suppose you have the TB X-rays, the tuberculosis X-rays. So to actually diagnose that, you should go to the radiologist. So what we are doing is, we are taking so many thousands of X-rays. We take the radiologist's opinion, what was there before, and we build a model, and we test and train those X-rays, and we come to a model. So if at all your X-ray, afterwards your X-ray is there, we need not go to the radiologist, we will put it in the computer, see the pattern, and it will detect whether you have the TB or not. That's what we are doing now in ICMR. Then, so artificial intelligence, it will be assisted also self-care, clinical advice, scheduling an appointment, nurse line, and ER direction. So everything can be used, nothing is impossible. But how effective your AI depends upon how you test the data, train the data. So what is the relation between AI and big data? If you want to have an effective AI, or what you call the AI should be very effective and very accurate, you should have the big data. Again, if you have the big data, your data also supposed to be accurate. You also should take care of all the measures where the data is accurate. So I don't want to bore with this. I am coming to directly to here. Yeah. Therefore, fueling the big data in healthcare revolution, you should have the precision medicine. Now the talk of the town, the talk of the world. Precision medicine, or they will, based on individual also they give the medicine, individual disease. And wearable and information technology, sensors, and machine learning. So these are all the three important aspects for the next 25 years where you can utilize the big data and artificial intelligence combination with statistics. This is your next 25 years, lot of revolutions are going to come. So, five predictions from the experts in future is, fast data and actionable data will come into forefront, privacy will remain a major issue, machine learning will continue to change the landscape, data volumes will continue to increase and migrate to the cloud, already been there in the cloud, data scientists and chief data officers will be in high demand. Please try now onwards. Okay, then. Now coming to my final thing, SWOT, strengths, weaknesses, obstacles, and threats. What are these 3 or 4 of the AI and big data? The strength is very powerful. AI techniques can unlock the clinically pertinent information hidden in massive data, aiding clinical decisions, making driven relevant clinical questions. And these are the strengths. There are so many 4-5 strengths. And this is the one which we are trying. We are taking the X-ray data and applying the AI technique, so that wherever there are no doctors, in the villages there are the facilities not available, only X-ray you can take and you can predict whether a person has the disease or not. Weaknesses, the training of data sets. I was telling you, if your data set is wrong, your entire process is wrong. In turn, it will affect the society. In turn, it will affect the individual. In turn, it will affect the patient. So therefore, the training and testing and good data, these are the main sources to get to successful AI computation. Obstacles, although AI technologies are attracting considerable attention in medical research, real life implementation still faces obstacles. So many of the, suppose they say that the sensitivity is 85%. That means that 15% there is an error. So there 15% is not a small thing. Therefore, you have to come closer to 100%. Then only your AI will be repeatable and applicable. Therefore, what are the threats? Less accuracy, less control, less privacy. So once AI started working, everywhere AI, then you will not have any privacy. Everything is. Therefore, now AI ethical guidelines are in vogue, and WHO also came out with AI guidelines, and ICMR also will shortly come with artificial intelligence ethical guidelines. So I just give an example and conclude my thing. You know Akshay Patra?
Yes.
What is that? Okay, you know that. I know you are murmuring. So Akshay Patra, an Indian non-profit with vision. No child in India shall be deprived of education because of hunger. To achieve this, the company's midday meal program provides one wholesome lunchtime meal to keep children sufficiently motivated, nourished to pursue the education. That is their aim. So what they have done? They have used the AI. It commercialized its 2 million meals served in 2016. AI is used to accurately forecast demand and information technology sensors, monitor and sequence cooking process to minimize waste. AI in combination with these other technologies expand its operation efficiently, meaning more children fed and kept in school. So therefore, every day almost they serve almost I think it is 2 million meals a day or 2.5 million meals a day. Per day they serve. They started with 1500 meals a day. So for that, how AI they using, how accurately you can reduce the waste, and how effectively you can increase the time, fastness, everything. So now Akshay Patra is using the AI tools. So that is the advantage of being a AI, then they are effectively using that. So therefore, for you in future, even at present, the technology might change. These are some of the Python, Cobra, Python, not Python. Python is a language, open source language, where it can be used. It's not Cobra, Python. Use it for this artificial intelligence tool. These are some of the tools which I think you can see there, and many more tools are available. Knowing tools is not very important. Knowing the concept is very important. Therefore, biggest impact by AI now is self-driving cars. I think self-driving without the even driver, self-driving cars. That is a very good innovative technology. I don't know how many they kill, but so far it's not on the roads. Trains already rule the rails in Europe. Boeing is building an autonomous jetliner. So this also failed once in I think it is in one of the South African countries. The flight has fallen with the AI. So lot of care should be taken. It's not so easy. It's a buzzword, but effectively it's very difficult to make it. Therefore, if implemented responsibly, AI can benefit society. However, as is the case with the most emerging technologies, there is a real risk that commercial and state use has a detrimental impact on human rights. So therefore, I also did some mistake here. This is also AI problem. Everything I repeated twice. So therefore, this is the danger, with the AI and robots. Robots will enjoy robot. But no, when it is the program is not properly done, it will do anything which is harmful to the society, isn't it? Yes. Therefore, I was telling to you that data quality is important. Before data is there, abundant data is there. So in this aspect, ICMR is also working on that, and we also worked on data quality issues, and before the survey, during the survey, and after the data collection, and we have released the data quality guidelines book by Secretary DHR, ICMR, Professor Balram Bhargava and Vinod Pal. They released the book which is developed by ICMR National Institute of Medical Studies, which is actually online, available freely. You can download and read. Very simple book. How to follow the data quality issues before the survey, during the survey, and after the survey. This book is open source available, and you can read it if at all you find the time. If at all better you find that time after you spending time on Facebook and Google. Okay. So now everything revolves on idea. So what is this? Facebook an idea. Facebook is an idea, isn't it? Everything idea. What is the idea you have? That depends. Coming 25 years, you come with some ideas. And see, I will give an example, final example before I conclude. With the same idea. Idea is same, but 3 people became billionaires. What is that idea? If I show you, you will laugh at me. This is the idea. See this. One person by writing became the billionaire, J.K. Rowling, Harry Potter. Another person by reading the books became the billionaire, is Warren Buffett. Another person by selling the books became billionaire, is the Amazon. The idea is one book has became 3 billionaires, but with different ideas. So that's what you youngsters need, idea. Idea will give you the, but if by reading Python, you will write a Python program. But now what is the idea that actually makes you successful and makes you successful, the country successful? So coming 25 years, it is the idea which you generate will make the country more proud. Thank you very much, the organizers of I really enjoyed speaking here. This is my birthplace. I have delivered so many lectures here. And thank you, Dr. Banu, for giving this opportunity. Thank you very much. And I wish you all the very best. Thank you.
Narasimha, lights.
So, as we conclude the last scientific talk of the Science Festival, it's been a wonderful journey for all of us. All the lectures have been live streamed and are available online for you to later see them. Each talk has been brilliant. We had a talk on biology, we had a talk on chemical technology, we had talks on pharmacology, talk on genetics, we had talk on space satellites, defense organizations, and finally the queen of sciences, I would say, the fitting tribute to all the talks, the artificial intelligence. The future of science is artificial intelligence, as rightly put forward. If industrialization has removed physical labor, artificial intelligence could well remove your mental labor as well and be more productive in other ways. So this is the future. The future of science is quite promising and should be used for the right purposes, or else we remember what happens as Sir always quotes his famous dialogue of what happens for a government employee for the first month. His first week of a month he is a socialist. Then the second week, because he keeps giving up money to other people, the next week he's a Democrat, where you try to bargain some money and take it forward, back and forwards. And then if you don't have any money, third week you will become a communist. Again, and if that also goes on, the last one is a terrorist. So you become a terrorist for the last week. Artificial intelligence might become that. So artificial intelligence might remove your jobs, but the future is quite prospective. So I was talking about ethical aspects of it. How do you use technology for a good purpose? That was Sir's key message. Sir has spoken about many things, but to us, Sir has always been the people's scientist. He's a people's scientist. From all the way from NIN, coming from director, he's never ever leaves any talk. He's the only guest, I suppose, who's also listened to the morning talk. Very few people have been so closely associated with NIN, and we are grateful to Sir to come here all the way from Delhi. Thank you, Sir, once again. Thank you for giving us wonderful talk. I now request Dr. Emily Brem sir to honor with Kanduva and Kanduva. We conclude the session and request the volunteers to take the respective batches to stalls. Thank you.
Those things have to be kept. Okay, no.